Close your hand around a die. Right now, inside your fist, it isn't a 6, it isn't a 2, it's every number at once, smeared together, undecided, not quite real. Open your hand, and it snaps into a single number. Not because the die changed, because you looked. That isn't a party trick. That is the tested behavior of everything smaller than an atom. Electrons, photons, particles, they sit as a fog of possibilities until something checks. Physicists call it wave function collapse. In plain English, reality doesn't finish loading until somebody hits refresh. Now zoom out. The universe is 13.8 billion years old. The first eye, a simple light-sensing patch on some ancient animal, shows up around 540 million years ago. Do the subtraction. That leaves roughly 13.26 billion years where nobody's hand was open, nobody was checking, stars ignited, galaxies wound themselves into spirals. Atoms fused into the exact chemistry that would one day build you, all of it supposedly, while undefined. A cosmos of spinning dice in a locked room with the lights off. We call this the measurement problem. Cute name for a crime scene with no witness and a body that very much arrived. Let's slow down because the universe checks itself is a dodge, not an answer. In quantum mechanics, a particle isn't a tiny ball with a hidden location. It's described by a wave function. Think of it as a cloud of every place the particle could be, each spot weighted by probability, not we don't know where it is. It genuinely isn't anywhere specific yet. It's the die in your closed fist, every face at once, real as math but not real as a place. The instant something interacts with it, a detector, a stray photon, an eye catching its light, the cloud collapses. One location, one value, one outcome. Fire particles one at a time through a wall with two narrow slits, and something absurd happens. Each one lands as a single dot. But let the dots pile up, and they paint bright and dark stripes, an interference pattern, as if each particle went through both slits and overlapped with itself, like two ripples crossing on a pond. Unwatched, they behave like waves. Watched, they behave like tidy little bullets and punch two clean lines. The particle acts like it knows you're looking, not metaphorically, measurably. In 1998, researchers at the Weizmann Institute in Israel ran a refined version using electrons and a detector delicate enough to watch a particle's path without shoving it. The interference pattern still vanished. Watching alone, no touch, no force, was enough to freeze the possibilities into one answer. Sit with that. The universe apparently demands a checker. And for 13.26 billion years, the checker's chair sat empty. For something with no plan, that timing is remarkably good. Here's where a footnote becomes a structural crack. If a possibility needs to be observed before it becomes a fact, then every fact baked into the early universe is a problem. The ratio of matter to antimatter that let anything survive the first second, the exact strength of the nuclear force that lets atoms hold together instead of flying apart. The rate of cosmic expansion, nudge it a fraction of a percent either way, and you get a thin, structureless fog instead of galaxies. And the cosmological constant, the number that decides whether stars can ignite at all, sits so finely balanced that shifting it by 1 part in 10 followed by 120 zeros erases every star in existence. All of those were decided, in the quantum sense, when, by definition, there was no observer, no eyes, no instruments, no minds. Just physics allegedly guessing, and never once guessing wrong. Physicists patch the hole with a word: decoherence. Interaction with the environment, they say, counts as observation. No consciousness required. Fine. But the environment is made of particles. And particles, by the same theory, need to be observed to become definite. You're using undefined things to define other undefined things and calling the math finished. It's a circle wearing a lab coat. Now compare that to anything humans actually build. A commercial airplane has about 6 million parts, and every single one is specified, measured, and inspected before it leaves the ground, because undefined tolerances kill people. We build in checkpoints. We build in inspectors. We build in observers, because we know that without checking, systems drift toward failure, never toward flawless, life-supporting precision. The early universe had none of that. No checkpoints. No inspectors, no eyes, and it drifted straight into stars, chemistry, and you. An accident that keeps passing an engineering review it was never supposed to take. So the sharp question, the one that pulls us forward, if a fact needs a witness, what, exactly, was in the room for the first 13 billion years? Suppose we cracked it. Suppose humanity figured out precisely what makes a possibility settle into a fact and learn to command it. What would that buy us? Computing first. Their quantum computer holds particles in that undecided fog on purpose, letting the possibilities interfere so the useful answers reinforce and the useless ones cancel out, solving in seconds what an ordinary machine couldn't finish before the sun burns out. Google's Sycamore chip and IBM's Condor are wrestling with this right now, and the fight is humbling in the most pathetic way. They cool the processors to around 15 thousandths of a degree above absolute zero, colder than deep space, and seal them inside vaults built to block every vibration, every stray photon, anything the system might accidentally treat as looking. All of it just to keep a few hundred particles undecided for a few millionths of a second. There's more on the table. Quantum encryption leans on this same watched versus unwatched behavior. Intercept a quantum-coded message, and the act of checking it leaves a mark, so it can't be spied on unnoticed. Quantum sensors built on the same collapse principle could catch a single molecule of disease years before a symptom appears. Europe's quantum flagship launched as a 10-year program with a budget near €1 billion. €1 billion to convince carefully guarded machines not to notice their own rooms. Meanwhile, the raw universe ran the opposite trick flawlessly for 13.8 billion years, not delaying collapse, but achieving it correctly everywhere at once, with no lab, no funding, no refrigerator, and as far as the textbooks will admit, nobody home. A single hydrogen atom does before breakfast what NASA has been chasing since the 1990s. A phrase you'll never find in a grant proposal. We assume it just happened. Randomness apparently set the hardest engineering exam ever written, and aced it without studying. So pull the threads. Every particle you're made of once existed as an unresolved cloud of maybe. Something turned that cloud into stars, into planets, into the precise chemistry needed to grow the very eye that would, billions of years later, finally open and start looking. The looking came last. The precision came first. We named it the measurement problem to make it sound clinical. It isn't clinical. It's a locked room, a spinning die, and a universe that walked out fully decided before there was anyone inside to decide it. 14 billion years of nobody checking. And when the first eye finally opened, everything it saw was already, impossibly, in place. So ask it plainly, the way the data has been asking it the whole time. If nothing was watching, who collapsed the die before the first hand ever opened?